Welcome to the presentation on more advanced ratio problems. Let's get started with some problems. So let's say that I have a class, and then let's see. Let me see. Oh, the pen is messed up. Let me see. Okay. So the class, in the class, the total number of students is 57, and I would also tell you that the ratio of girls to boys is equal to 4 to 15. So now this is the interesting part. So far it doesn't look too tough. My question is, how many boys need to leave the room? So how many boys need to leave for the ratio of girls to boys to be 4 to 11. This is fascinating. So a good place to start is just to figure out how many girls and how many boys there are in this classroom. And we already learned how to do that in the introduction to ratio problems. We know that the girls plus the boys is equal to 57, right? Because there are 57 total kids in the room. And we also know, just taking this equation and multiplying both sides by b, we also know that the girls are equal to 4 over 15 times the boys, right? And then we can just substitute that back into this equation. And then we get 4 over 15b plus b is equal to 57. And this is the same thing as 19 over 15b is equal to 57. Let me clean this up a little bit. That's separate, and then let me go here. And then we say b is equal to 57. It's actually 57 times 15. All of that over 19, right? I just multiplied both sides by 15 over 19. So 57 divided by 19 is 3. So b is equal to 45. And we know that there are a total of 57 kids in the class. G plus b is 57. So we know that there are 12 girls, right? 57 minus 45. Good. So now we know that the current boys and girls are 45 boys and 12 girls. So let's write that down. So there's 12 girls and 45 boys. Now, the question says how many boys need to leave for the ratio of girls to boys equals 4 to 11. So this is the number of girls right now, 12. This is the number of boys. Let's say x is the number of boys that need to leave the room. So if x boys leave the room, the new ratio will be 12 girls to the 45 boys minus the x boys that leave, right? Now, if that confuses you, sit and look at that for a second. We start off with 12 girls and 45 boys in the room. And we're saying that x boys are going to leave. So the new ratio is going to be 12 to 45 minus x. And we know from this part of the problem that that new ratio is going to equal 4 to 11. There, we just set up an equation with one unknown, and we can solve for x. I hope that doesn't confuse you much. All we did is we figured out how many boys, how many girls are in the room now. We said x is the number of boys that need to leave. And then we said the new ratio is going to be girls to the new number of boys, which is 45 minus x, and that's going to be equal to the new ratio. So let's solve for x. Well, 12 times 11 is, what, that's 132. 132 is equal to 4 times 45, 160, 180 minus 4x. And then if you solve for x, and I think you know how to do this right now, and we could say, we could say minus 4x is equal to minus 48. X is equal to 12. There, we solved it. So we say that if 12 boys left the room, the new ratio of girls to boys would be 4 to 11. And does that make sense? Well, if 12 boys left the room, then the ratio of girls to boys would be 12 to 33, right? Because 45 minus 12 is 33. And if that's the same thing as if we divide the top and the bottom by 3 as 4 to 11. So there, we got it right. So it looked like a very hard problem. Actually, wasn't so bad when you just sit down and work through the algebra. Let's do another problem. Let's say, this thing sometimes malfunctions. Okay, let's say that the ratio of apples to bananas in a basket is equal to 5 to 19. And when we add 23 bananas, the ratio of apples to bananas, and actually let's just write it right now. We now have 23 bananas more, is equal to 10 to 61. So the question is, what is the total amount of fruit in the basket? Amount of fruit. That's so messy. After adding the bananas. So I actually give you a hint just when I wrote down the initial problem. We're saying that the ratio of A to B, so let's A equal the number of apples and B is equal to the number of bananas. So the ratio of apples to bananas equals 5 to 19. When I add 23 bananas, so now the new ratio is going to be the number of apples to B plus 23. The new ratio is 10 to 61. So how do we solve this? Well, once again, we have two equations and two unknowns. We know that, I guess let's take this equation first because it's a little more complicated. We know if we cross multiply that 61A is equal to 10B plus 230. And if we divide both sides by 61, we know that A is equal to 10 over 61B plus 230 over 61. All right? And we could take this equation and multiply both sides by B, and we say that A is equal to 5/19 B. All right? Well, both of these are equal to A, so we could set them equal to each other, and we get 5 over 19B is equal to 10 over 61 B plus 230 times 61. And we solve for B. Well, this might seem complicated to you at first, but it's just a basic linear equation. And for the sake of time, because I only have 2 minutes left in this YouTube, I'm just going to solve for B, and you get B is equal to 38. If B is equal to 38, we know that the initial ratio is 5 to 19. So that's pretty easy. We just say A is equal to 5 over 19 times 38 is equal to 10. So the initial number of apples was 10. The initial number of bananas is 38, right? So initially, we started off with 48 pieces of fruit. And then we're going to add 23 more pieces of fruit, right? And 43 plus 28, that's what? 71 pieces of fruit. So let me review real quick what we said. We said that the ratio of apples to bananas is 5 to 19. And that's A is the number of apples, B is the number of bananas. When I add 23 bananas, I now have B plus 23 bananas. The new ratio of apples to total number of bananas is 10 to 61. And I just used both of these equations, two equations and two unknowns, solved for A, and then substituted, and then I solved for B. Nothing fancy here. I know there's a lot of fractions here, but if you just work through this, that fractions actually work out. And I was able to solve for A and B, add the 23 pieces, and I got 71 total pieces of fruit. I think you're now ready to try some of the more difficult ratio problems. Have fun.